Welcome to this video. This is lesson 6, changes in dimensions of 3D shapes. Here's our agenda for this lesson. We're going to start with our objective and our big idea, talk about the new material, try some practice problems, and then I'll leave you all at the end for the IXL to do on your own. Here is the objective for this lesson. Students will determine the surface area or volume after a change in one or more dimensions. And again, our big idea here is area and volume. So this is going to be our guiding question throughout this lesson. If I change the length, width, height, or radius, what happens to the volume and surface area of a shape? So take a shape like this. Let's say I double the height or double the width. How is that going to change the new volume, the new surface area of the shape? That's what we're going to be figuring out. And the big idea is that the formula is key. The formula is going to tell us everything we need to know about how the volume and surface area are changed. So here are the steps we're going to use to solve these questions. Step 1, write the formula for surface area volume. Step 2, what is being changed? Fill that into the formula. And then step 3, simplify and compare to the original. The first shape we're going to talk about is a cube. Here are two new formulas here for you. Volume equals s cubed and area, surface area equals s times 6 squared. These formulas are just derived from the previous formulas, but because it's a cube, this is what they end up being. So let's look at this question. If the side lengths of this cube are doubled, so that's going to be 2 times bigger, what will happen to the surface area and volume? So step 1, write the formula. Let's start with volume. So volume is going to be s cubed. Now step 2, what is being changed? Fill it into the formula. Well, the side lengths are all doubled, so this is now going to become 2s cubed because each side length is now 2 times bigger. Step 3, simplify and compare to the original. Now I got to take this cube and I got to do it to the 2. 2 cubed is 8, so now I have 8s cubed. Now if I compare this to the original, you see that it's 8 times bigger. So that's going to be my answer here. The volume is 8 times bigger. Let's talk about the surface area. Same sort of thing. Let's fill it into the formula, but instead of s, I'm going to put 2s because it's 2 times bigger. That's going to give me 6 times 4s squared. And we notice that if we compare this to the original, it's 4 times bigger. So that's how we get our answer there. Let's try a cylinder. Same process, but with different formulas. Here's a question. If the radius is doubled and the height is tripled, what will happen to its volume? So let's write the formula we're interested in. And instead of r, I'm going to write, because it's 2 times bigger and the height is tripled, that's 3 times bigger, I'm going to write 2r squared. Instead of h, I'm going to write 3h. Now let's simplify this. 2 squared is going to give me 4r squared, and then of course 3 there is still there. This 4 and these 3 are going to multiply and actually give me 12 pi r squared h. So in other words, the volume is going to be 12 times bigger. And that is my answer, 12 times bigger. Okay, what about a prism? So let's say that the length is halved and the height is tripled and the width is not changed. What will happen to its volume? So let's write a formula we're interested in. The length is halved, so 1/2 of the length. The width is not changed, and then the height is tripled, so that would be 3 times bigger. This is 3, this is 1/2. 1/2 times 3 is actually 3/2, so I know it's going to be 3/2 times bigger, or 3/2 times bigger. What will happen to the surface area if all the dimensions are tripled? So we're changing it up. Now all the dimensions are being tripled. How does that affect the surface area? Well, for a prism, I've got to use this formula, and I'm plugging in 3 because they're being tripled. So it'd be 2 times 3w times 3l. This formula is actually just the sum of all the faces. It's just written concisely. So each of the faces, the dimensions are now 3 times bigger. So let me write this out here. Okay, now if I simplify this, each of these things is going to give me 9. 3 times 3 is 9, 3 times 3 is 9, and 3 times 3 is 9. So as it turns out, it's going to be 9 times bigger. Now you're probably wondering, what about this 2 here? Actually, I'm not going to worry about it because the 2 is in the original formula and I'm comparing. Remember that. So it's 9 times bigger, the surface area. Alright, let's talk about the next shape of cone. If the radius and slant height are tripled, what will happen to its surface area? So we're talking about surface area, we're going to use this formula. So I would do pi, and then it's going to be 3r, because both of them are tripled. And then 3r again, plus the slant height is 3 times bigger, so 3l. Now, actually, I can simplify this in the following way. Both of these terms have a 3, and I can actually pull it out like this. That's called undistributing. Now this 3 and this 3 are going to multiply and give me 9, so I know that it has to be 9 times bigger. Surface area is 9 times bigger when the radius and slant height are tripled. Alright, last shape, sphere. If the radius is halved, what will happen to the surface area and volume? So let's quickly do the volume. I think the spheres are the easiest. Plug it in here, we're going to do half r, and that's cubed. Cube transfers over to the 1/2, and 1/2 cubed is actually 1/8. So it's going to be 1/8 times smaller, actually. It's going to shrink. And then what will happen to the surface area? Well, it would be 4 pi times 1/2 r squared. This squared transfers to the 1/2, and that's going to give me 1/4 times smaller. And that's it. Alright, that's it for this lesson. Now it's time for y'all to practice. Here's the IXL to do, Geometry T10. Please, if you need help, send me an email or join me during my office hours on Zoom. I would love to talk about it. Best of luck.